have you write the work for these problems on a separate piece of paper and the 5 words that let me know that you watched this from beginning to end. So again, do the work only. You do not need to write down the word problems themselves, just the work that I'm showing you here and the 5 words to show that you listened. So here we go, problem number 1. And again, these are the test questions, so thank you for taking the time to watch. Alright, the first one is the age problem, where you're seeing who these two people are being compared to. And it says I'm comparing Bill to Tim, and I'm also comparing Joe to Tim. That means the person being compared to twice is Tim. He gets the variable because he's the one compared to Bill and he's the one compared to Joe. So with that, I could do all the other ones algebraically based on Tim. I know that Bill is 8 years older than Tim. So for Bill, I'll use x plus 8 to show Tim's age plus 8. 8 years older than Tim. There's Tim. Bill is 8 years older than Tim. Joe is 4 times as old as Tim. Joe is 4 times as old as Tim. So there's Tim right there, that blue X, and then multiply by 4, that will give me Joe's age. If I add all 3 of these, it should equal that 38, their combined age, that total. So this expression sets it up equal to that 38 will give me the equation. And then you're going to combine all my x's and leave that 8 alone. Those x's combine to give me 6. 1, 2 plus 4 more, 6x. Bring down the 8, the equal to 38. Take away 8 on both sides, and that gives you 6x equal 30. And then right there, the opposite of timesing by 6, dividing by 6, gives me x equals 5. But realize that x is the age for Tim. I need to take that 5 and put it in all these spots for x to show me the math. So take that 5, which represents Tim's age, put it in here, put it right here, add it to 8, and times it by 4. So Tim's age, the first word is green. Green is the first word. So I take Tim, and I just put that 5 right there because Tim is just 5 years old. And then for Bill, if I put that 5 right there for x, I'll get 5 plus 8 will give me Bill's age, which is 13. 5 plus 8, 13. And then if I take that same 5 and put it right here for Joe, 4 times that 5 will give me 20. And if I want to double check, if I take all those ages, Joe's age of 20 years, Bill's age of 13 years, Tim's age of 5, if I add these up, it should equal 38. In fact, it does. 5 plus 13 is 18, plus that 20 is 38. So you could always check on these to see if you're right. All right, the next problem. This one is the kind of problem that we looked at today, the per problem, where you're taking the $10 per day, where x will represent your number of days, $10 times each day, plus your $40, and you're going to see if you set that equal to 240 what the number of days would have to be. So here I go. First one, $10 per day. That means I'm going to take $10 times it by the unknown amount of days. I'm going to use x. So 10 times the number of unknown days, 10x, plus that 40 equals the $240 charge. But again, this is what will give me how much I spend for each day. If I spend 1 day here, 1 day, 10 times 1, 10 plus 40 plus 10 is 50. If I rented it for 2 days, 2 times 10 is 20, plus that would be 60. But I'm seeing if my final price is 240, what x would have to be, or how many days that would have to be to get that value. So 240 goes right here, and then that becomes a 2-step equation where I minus 40 on both sides, bring down the 10x, 240 minus 40 is 200, divide by 10 right there, and I get x equals 20. And you got to know what that means. That x equals 20, that is not 20 hours. That's not $20. That is 20 days. Make sure you have the right unit in there. 20 days at this price per day with that deposit. You could always check by taking that 20 and plugging it in and seeing if 10 times that 20 plus that original 40 equals 240, and that should work because that gives you 200 plus 40, that is 240. The third word is whale. Whale. All right, on to the third problem here. This one, consecutive integers, which are numbers right in a row, like 5, 6, 7, or 8, 9, 10. So if I don't know the three numbers, we always start with the first one to just be x. And then, of course, to get the number after that, I just take x and just add 1. That will give me the very next number. And then to find that third one, I take that original x and I add 2 to it. That will give me the three numbers. So for example, if I eventually find out the first number is 10, 10, 11, 12, I get that by taking 10, putting 10 right here. That's from 10 plus 1. That's where I get the 11, the second number. And then when I put 10 right here, 10 plus 2, that gives me 12. That's what these mean. Once you find that first one, to find the number right next to it, you just add 1. And then you're going to add 1 more to get that 10, 11, 12 pattern, or 13, 14, 15 pattern. So for this problem, I'm going to add up all three of these. This x to represent the first number. This is the second. This is the third number in a row, equal to 96. And then back to the problems we've been doing. You combine your x's and your two plain numbers. So all those x's combine to give me 3x. That 1 and 2 combine to give me 3. 96 stays 96. Solve that two-step equation by subtracting 3. Bring down the 3x, the equal, and this is 93. Divide by 3, and you get x equals 31. That is the first number. Don't stop right there. A lot of you stopped and said that's the answer, but that's only the first number of 2 more I need. So I need you to say and put that x in here and show me the math, and then give me the actual numbers. So the first number, of course, is 31. The second number comes from taking 31 plus 1, but don't just write 31 plus 1. Actually finish that out and write that as 32. That's what I'm really looking for. And then the third number, 31 plus 2. And again, don't just leave it 31 plus 2. Add that up. Get that 33. Those are the three numbers. And of course, you could check your work by adding all three and seeing if they add up to be 96. And yes, that should, because this gives you 63. And then 63 plus 33 does give me 96. So I know that works. All right, the fourth problem. All right, this one, again, is kind of like the age problem. But instead of me comparing 3 people, I'm just looking at just 3 numbers. The first number, second number, and the third number. Kind of similar to the age problem that we just did. The third word is under. Under. All right, so back to this comparison problem. We're looking to see which number got compared to more than once. So I'm looking, the second number is 8 more than the third, and the first number is 6 times the third. Since I'm talking about the third number twice there, that's the one I'm comparing everything to. I'm comparing the second number to it, to the third one, and I'm comparing the first number to the third one. So that means the third one is the one that gets the single variable, because all the others are based on that third number. So here we go. The second number is 8 more than the third. So that would be the third number right there. There it is. Plus 8. 8 more than the third number. The first number is 6 times the third. So there's the third number right there, that red X. 6 times, that's 6X. So there's the third number being compared to twice. There's the second number, which is 8 more than the third. And then there's the first number, which is 6 times the third. And if I add these three up, I'm going to know that they add up. The sum of these, adding these three up, equals 72. So there's the first number, second number, and then there's the third number, equal to 72. So I'm going to combine my like terms here. 6, 7, 8. Give me 8 of those x's plus 8 equals 72. I'm going to subtract 8 on both sides. Bring the 8x down. 72 minus 8 is 64. Divide by 8. And realize when you get that answer, x equals 8, that is the third of the numbers. That's the third one. That x goes right here. So if I take that 8 and plug it in to the other x spots, I'll get the first and second number. So the first number is 6 times that 8 that I know x is, which gives me 48. The second number is 6 plus that 8, which gives me 14. I'm sorry, 8 plus that 6, plugging in 8 right there. 8 plus 8 gives me 16. And that third one is just 8, because there's nothing to do once you put that 8 right there. And to double check my work, if I add all three of these, it should equal to 72. That should work. 48 plus 16 plus 8. 48 plus 16 gives me 64 plus 8, and that gives me 72. That does work. All right, next problem. The fourth word is sky. Sky. All right, this one is a perimeter problem where the perimeter is adding up the lengths all the way around the rectangle. The two lengths and the two widths all the way around. So the first one on this, get the very first information that they've given you. They're telling you when I add up all of them, they give me 50. But then the next line says the length is 5 centimeters more than the width. That's translated literal like that. Length L is your equal the width plus 5. So the length is 5 more than the width, which means I'm comparing the length to the width, which means everything's involving around the width. The length is a little bit more than the width is the width. So I'm going to use W as my unknown here. And when I put those pieces in the right spot, here's the length, which is longer than the width, 5 centimeters longer. Here's the two widths. If I add up all of these sides, it will equal the all the way around perimeter. Add up all 4. So there's the bottom, there's the side, there's the top, there's the left side, equal to the perimeter number, which is 50. And then again, combine all your like terms, combine your two plain numbers. All those W's combine to give me 4 W's plus that 10 equals 50. And then right there, I'm just going to subtract 10 on both sides. Gives me 4W equals 40. And again, I'm going to change that back to an X. Don't put an X in there. Keep staying with W's. W's, don't change it to X's. So I'm going to change that here in a little bit. I realize, what? Don't go from W to X's. So I'm going to fix that right here. Keep it W. So 4W. So when I divide by 4, I get W equals 10, not X equals 10. And then when you have that W equals 10, you should know that that's the width. That's not the length, that's the width. So if I take that 10 and put it right here, there's my width. And if I put that 10 right here, that will give me my length. So here I go. My length is that width number 10 plus 5. That gives me a length of 15. And my width is just going to stay 10. If I want to double check my work, if I drew a little rectangle and put those pieces as 15 and 15 on top and bottom, for the two lengths and then 10 on the side. If I add all those up, it should equal to 50. So again, back to this one. If I add up these three pieces, or all four, it should equal my perimeter 50. So it does. All right, on to, I believe, the last problem here. And that does equal 50. All right, the last one is going to be one more of these per problem. So $5 per person. $5 per person is 5 times X plus that original fee of 30. So plus 30 equals 90. So right there, that 5x plus 30 again shows you how much you're spending. I want to know if I spent 90 using that expression to write this as an equation, I could solve this for x and see how many people I bought. So 5x, bring that 30 away. 5x comes down. 90 minus 30 is 60. Divide by 5. And that gives me x equals 12. So that tells me I bought for 12 people, not $12, not 12 hours, 12 people at this price. And of course that makes sense, because if I times 5 times 12, that's 60. 60 plus 30 gives me 90. So that's true. 12 people I spent for. The last word is blue. Blue. And of course, if you wanted to check this, you could have by plugging that back in, but you don't need to. So good luck.